Hello guys, welcome to Ramta Solutions. In today's video, we're going to show you how to ace grade 12 trigonometry exam questions. So you are wondering why we are emphasizing acing this topic. This is because this topic has about 50 marks, right? This topic has about 50 marks. Okay. So you can imagine 50 marks. That says if your paper, you know that your paper is equal to 150. So mastering this topic means you have 33.3%. Right. So this topic accounts for 33.3% of your mathematics paper 2 exam. Right. So you can see that this topic is quite important. Okay. All right. So now, what to look out for? So what to look out for? We are going to break this video. It's going to be a long one. We are going to break this video into aspects of your topic. One, you need to recall what is SOHCAHTOA. All right. Then we will proceed to special angles. Okay. You then recall that you have the cast diagram. So this is still grade 10 trigonometry. Then we go to grade 11. We're going to look at reduction formula. Right, reduction formulas. Then we go to identities. I wanted to follow with general solutions instead of identities, but I will choose the sixth item we will look at is sine rule, cosine rule, and area rule. Okay. The seventh aspect will be trig functions. And because we want to explain general solutions so that you understand it forever, we then conclude this video with general solutions. We will try to have examples where possible. Okay, so these are the things that you are looking for in your grade 12 trigonometry exam questions. Okay, not saying that they come in this manner, but all of them are important. You need to know them before you get into your exam. Okay, now let's start. One, let's remind you of SOHCAHTOA. SOHCAHTOA, you recall what it is. Only applies for right angles, triangles. Okay, it's only for right angled triangles. Okay, it's only for right angled triangles. So let's imagine this triangle here. Let's say the side here is 3 units. This one here is 5 units. And this is theta. We can find the unknown, which is the hypotenuse, by using Pythagoras theorem, because this is a right angle triangle. So it'll be 3 squared plus y squared. 3 squared plus 4 squared. This is equal to 25. Therefore, R is equal to 5 units. Right? So R is equal to 5 units. Right. So we said this is equal to 5. This is a right angle triangle. This is theta. So we can say, let me reduce the size a bit. Then we can say this angle here must be 90 degrees minus theta. Okay, perfect. So with SOHCAHTOA, we then say, for example, that sine is equal to opposite over hypotenuse. Now, let me just say sine theta and not just sine. Sine theta here is equal to opposite over hypotenuse. What side is opposite theta? It is the 3 unit side. Which side is the hypotenuse of this right-angled triangle? It is one that is 5 units long. So sine theta is 3 over 5. Now let's go to cos theta. Cos theta is adjacent over hypotenuse. And adjacent over hypotenuse. Which side is adjacent to angle theta? It is this 4 unit long side. And what is the hypotenuse? The longest side of a right angle triangle, one that is 5 units long. Then let's go to the tangent. Let's look at the tangent. So with the tangent, we're looking at tan theta. What is it? Tangent. We said SOHCAHTOA. It's opposite over adjacent. All right, it's opposite over adjacent. All right, so which side is opposite theta? The 3 units long side. And we said the adjacent is the 4 units long side. Okay, so this is how you do SOHCAHTOA. But now, what if they were asking you for now sine? Let me change the color. What if now they were asking you for sine? This green is not that bright enough. Which one should I use? Okay, let me use this yellow. Hoping it's better. Nah, worse. Okay, let me use red. So what if now we're saying sine 90 minus theta without using co-ratios? So sine 90 minus theta, as you can see, this is sine 90 degrees minus theta. Which side is opposite it? It is 4, isn't it? So this one will be 4. The hypotenuse is still 5. Now let's go to cos 90 degrees minus theta. Which side is adjacent 90 degrees minus theta? It is the 3 units long side, which is 3. Now the hypotenuse, we said it's 5. Right? Lastly, let's go to tan 90 minus theta. Tan 90 degrees minus theta will be opposite was 4, adjacent was 3. So it's 4 over 3. I hope you guys now are okay with this. So this is your SOHCAHTOA. The second aspect that we going to look at, or we have to look at, is special angles. Okay, these special angles. So you need to know your special angles. 2 special angles. So now special angles. Special angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and I must say, and their multiples. Okay, of course, multiple of 30s are 30, 90, 30, 60, 90, 120. They are multiples. Multiples of 45, 45, 90, 135, 270, and so on. Multiples of 60, 60, 120, 180. Multiples of 90, 90, 180, blah, blah. All right, so I'm saying, and they are multiples. Okay, and they are multiples. Okay, and they are multiples. Those are special angles. Okay, so you may need to know them off by heart, or otherwise simply pressing them on your calculator would help. Okay, simply pressing them on your calculator would help. However, I know the section will be saying do not use a calculator, but hello, it's not like they are policing you if at that particular section you're using a calculator or not, right? But it's good that you know how to solve them without using, or to determine them without using a calculator. So I will say draw a horizontal line and a vertical line like this. Assume that the lines are equal. In between these lines, draw 3 other lines. Once again, assume the lines are equal. Begin from the top. Say, as you begin from the top, say, for example, this start with, in fact, not say, for example, start numbering 0, then 1, 2, 3, 4. Okay. Then from the bottom, start numbering, put semicolons next to each number that you wrote. Then from the bottom, write 0, go up 1, 2, 3, 4. Right? Put square roots on all of them. Yeah, there's no need of putting a square root on 0, right? There's no need of putting a square root on 0 and 1 as well. All right? There's totally no need to put in square roots there. So these ones, we basically can say they are 0 and 2, and this one is 2 and 0. So these are like coordinates. Okay? Are like coordinates. So for example, now let's see. Using this, by the way, the first line represents 0. So this is 0. This is 30. Okay, 0. This is, okay, let me just do this. So this is 30. This one here is 45 degrees. And this is 60 degrees. Each point represents x and y coordinates. Okay. So let's say, for example, you're looking for sine 30 degrees, and then you're looking for tan, okay, tan 45 degrees, and lastly, tan 60 degrees. Tan 60 degrees, and maybe here, should I add more? Yeah, let me add more. But I don't have to, guys, because you can just get these values straight from your calculator. Okay. So you say, okay, tan, if I look at it here, opposite is this value here, which is y. So tan will be y, and hypotenuse, by the way, I must tell you, hypotenuse using this shape here, or this figure here, is always 2. So you say, okay, opposite for 30 degrees is y, right? So it's 1 in other words. So this is 1 over 2. On your calculator, if you can press that, tan 30, sine 30 degrees, you will find half. Let's go to tan 45 degrees. Tangent is opposite over adjacent. Opposite is y value is root 2. Adjacent is x value is also root 2. Hence, if you press tan 45 on your calculator, you will get 1. Now let's go to tan 60. Opposite, once again, is y value is root 3. And then adjacent is x value, which is 1. So tan 60 degrees is root 3. In the same way, how about we try cos 0 degrees and also sine 90 degrees. Once again, cosine is adjacent over hypotenuse. Adjacent is the value of x. What is the value of x here? It's 2. And hypotenuse is 2. Now what is cos 0? It's 1 indeed. Sine 90, here is it. Alright? Here is it. Sine is y over hypotenuse. Y here is 2. And the hypotenuse is 2. So indeed, sine 90 is 1. right? And this is your special angles. Of course, even if you don't do this diagram, you can just press the values on your calculator and get them. Okay. Now I need to tell you something. I want to check. There's also tan 30. Let's try tan 30. Tan 30. Okay, let's try tan 30. Tan 30, when you look at this diagram, tan is opposite, which is y value. Y value is 1. And then what is its x value? Its x value is root 3. If you like, you can rationalize the denominator. When you rationalize the denominator, you will multiply by root 3 over root 3. Now, as we proceed now, we then say, okay, numerator times numerator, 1 times root 3 is root 3, and root 3 times root 3, right? Root 3 times root 3 is 3. However, this is what you get directly on your question, on your calculator. So this is also a good idea. This one indicates that you used your calculator. Okay. But this says, the child didn't use a calculator. So this child is good. So rather go for this one here. Okay. All right. Perfect. Moving on. Let's then head to the cast diagram. Let's then head to the cast diagram. You've wondered why you have a cast diagram, right? Though it is not yet the time to talk about trig functions, but since you're in grade 12, I guess it won't kill to just draw simple trig graphs. All right. I guess it won't kill to draw simple trig graphs. So let's say 90, 180 degrees, 270 degrees, and then 360 degrees. So let's say this is 1, this is -1. I'm going to begin by saying for the sine graph, it is like this. Then the cosine graph, sorry, once again. So the black one is the sine graph. The black one is the sine graph. Let me change colors. The red one will be the cosine. Good. Good. This one is cosine. All right. Then let me try tangent. The first asymptote is at 90 degrees. And then the second is at 270 degrees. Okay, perfect. So the third one is tangent, the tan graph, right? So your cast diagram is coming from this information here. So we say we work with, for example, let's just say this here. Let's say this is X, this is Y. So now let's start. I will label these things. Look at this. From 0 to 90, we call it the first quadrant. From 90 to 180, we call it the second quadrant. From 180 to 270, we call it the third quadrant. 270 to 360, we call it the fourth quadrant. Right? Now let's talk. In the fourth quadrant, which ratio is positive? As you can see, it is all of them. In the second quadrant, which ratio is positive? Remember, to see the one that is positive, we're saying it is appearing in the positive y-axis. It is only the sine. So only sine is positive. Then we go to the third quadrant. Which one is positive? Ooh, it's the tangent. It's the tangent. And then for the fourth, It's the cosine. Right? Is the cosine. Now, as you can see now, the cast diagram is coming from this fact. Okay, it's coming from this fact. Let me just reduce it and say, yes, you have said all okay. All students take coffee. So now you understand where it comes from, right? Now you understand where it comes from. So you happy? Great stuff. Now let's move on. We're done with it now. Let's go to the next item. Now, we then proceeding to the reduction formula. This is item number 4. Item number 4 is the reduction formulas. So here we are saying angles greater than 90 degrees can be written as acute angles. Can be written as acute angles. Okay. Now, with reduction formula, we have now, once again, using the cast diagram, we will say in the first quadrant, we are using the reduction formula 90 degrees minus, let's say, theta. Okay, let's say theta. Then in the second quadrant, we are using 90 degrees plus theta, or 180 degrees minus theta. In the third quadrant, we are using 180 degrees plus theta plus this is minus theta. In the fourth quadrant, we are using 360 degrees minus theta. So remember, theta is an angle, is an acute angle. So any acute angle you can think of, if you subtract it from 360, it will always be greater than 270. Any acute angle, if you add it to 180, it will always be greater than 180 but less than 270. I hope you get it now. So this is how you, these are your reduction formulas. Okay, these are your reduction formulas, but I have to give examples here. So examples: calculate number 1. I'm gonna say sine 135. This we can do in 2 ways, and then so let me leave 2 lines forward, and then tan 225, and thirdly cos 210. So tan 135, the question you should ask yourself is this: where is it? It cannot be in the first quadrant. Remember, in the first quadrant, basically, if you like, you can say, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and coming back 360 degrees, right? So 135 is in the second quadrant, right? In the second quadrant, we work with 180 minus. So 135 and 180, the biggest is 180. So say 180 minus 135. Your answer is 45 degrees, isn't it? Therefore, we can say this reduction formula will be 180 minus 45 degrees. Now, you then say, okay, sine in the 180 minus, is it positive or negative? 180 minus is the is the second quadrant. Now, as a reminder, we said all students take coffee. Okay, so sign in the 180 minus is positive. So, okay, positive. So it'll become positive sign. Then you get rid of the 180. It is now becoming positive sign 45 degrees. Because we did special angles, this is positive root 2 over 2. Right? Alternatively, this one we can say sine 135. We said it is in the second quadrant. Right? In the second quadrant, we also work with 90 plus. So you then say, which one is bigger between 135 and 90? It's 135. So say 135 minus 90. It gives you 45 degrees. All right? Perfect. Then proceeding, we will say this becomes 90 plus 45 degrees. Now, sign in the 90 plus quadrant. Which quadrant is that? The second quadrant. Is it positive or negative? Oh, you say it's positive. So it'll be positive sign. Get rid of the 90. But hold on. This is 90. So since it's 90, the sign has to change to become cosine. I repeat, how you do this? You say, follow me. Sign in the 90 plus quadrant. Is it positive or negative? Which quadrant is the 90 plus? Is the second. So sign is positive. But hold on. This is not 180 or anything. It's 90. If it's 90, the ratio must change. It will now become cosine. So it becomes cos. You drop the 90 and use the acute angle. What is cos 45? It is still root 2 over 2. Happy? Perfect. Now let's go to tan 225. Where is this angle? 225 is greater than 180 but less than 270. That means it is in the third quadrant. In the third quadrant, we work with 180 plus. All right? 225 and 180, which one is greater? 225. So 225 minus 180 will be 45 degrees, isn't it? Perfect. So this will be 180 plus 45. I repeat, 180 plus 45 is equal to 225. So tan in the 180 plus quadrant, is it positive or negative? It's positive. And then it's 180, so it doesn't change. Then it's going to be positive tan 45 degrees. Now, what is tan 45 degrees? Previously, we found that it is equal to 1. Happy? Previously, we found that it is equal to 1. Right. Perfect. Now, let's go to cos 210. 210 is also in the third quadrant. So it's 180 plus. Oh, 210 on 180. The biggest is 210. So 210 minus 180 degrees would be 30 degrees. So that means 210 is 180 plus 30 degrees. Now, 180 plus is in which quadrant? We said the third quadrant. In the third quadrant, is cosine positive or negative? It is negative. Now, because it's 180, it doesn't change. Therefore, it will become negative cos the acute angle 30 degrees. We showed you how to get special angles. Using that figure for special angles, you will find that cos 30 is root 3 over 2. If you press sine 135 degrees on your calculator, you will get root 2 over 2. If you press tan 225 degrees on your calculator, you will get 1. And if you press cos 210 degrees on your calculator, you will get negative root 3 over 2. So this is your reduction formula. But now I said, with the reduction formula, I said angles greater than 90 degrees can be written as acute angles. Let's see. You initially had sine 135. it is now written as positive sine 45 degrees. All right, positive sine 45 degrees. Right? You then had sine tan 225 degrees. It is now written as positive tan 45 degrees. In the same way, cos 210 degrees, it is now written as negative cos 30 degrees. I hope you guys see it now. Happy? Great stuff. Let's go, guys. So now we then proceed to identities. It's key that we look at identities. So the fifth aspect is identities. You need to know these identities. Some are given, if not all, but most of them are given. So the first identity you learned about in grade 10 was sine square theta plus cos square theta equals 1. Then you also learned that sine theta over tan sine theta over cos theta equals tan theta. I want to use co-ratios. I think I should introduce this co-ratio. Then sine 90 degrees minus theta will be equal to cos theta. And then cos 90 degrees minus theta will be equal to sine theta. So these, we call them co-ratios. Let me just add them here in the section of identities. Okay, so these are the identities. So these are all that you have learned from grade 10 and 11. Now let's introduce ones for grade 12. For grade 12, you then introduce compound angles. You then introduce compound angles. They are sine, let's say, I've been working with theta. So let's say theta plus beta will be sine theta cos beta plus, because it's sine, it's going to be plus cos theta sine beta. Then let's try minus. So theta minus beta will be sine theta cos beta minus cos theta sine beta. Then let's go to cos. I'm going to start with theta plus beta. This then becomes cos theta cos beta. Because it's a plus, it'll become a minus sine theta sine beta. Then let's try cos but with a minus. So this then becomes again cos theta cos beta. Because it has a minus, it'll become a plus sine theta sine beta. So these formulas are given in your data sheet. Okay, if you do not know them off by heart, they are given in your data sheet. Okay, they are given in your data sheet. Another identity that you will be given is double angles. So this is your grade 12 syllabus, right? Double angles. So with double angles, let's start with sine. I'm going to use alpha theta rather, sine 2 theta. The double angle for sine 2 theta, its identity is 2 sine theta cos theta. Then let's look for the double angle of cosine. Cos 2 theta, we have 3. You can use cos square theta minus sine square theta. Then, using that identity of x sine square theta plus cos square theta equals 1, you can manipulate it in terms of x, in terms of cosine, you will get 2 cos square theta minus 1. In terms of sine, you will get 1 minus 2 sine square theta. So these are the identities that you use in grade 12. So these ones, the compound angles and the double angles I just mentioned now, their formulas are given. Okay. Their formulas are given. Okay. Now moving on. Let's now try some examples. Okay. We are now going to try some examples. I think I might take 1 or 2. All right. So these examples might be for, in fact, let them be for almost everything we have done. Okay, let them be for almost everything we have done. Okay, so we will try here and say, and oh, I need to tell you guys, you may be required to prove these, right? May be required to prove this. Okay, may be required to prove these formulas. Okay, may be required to prove these formulas, and not just those, even these ones here. Okay, even these ones here, you may need to prove them. The exam may ask you to prove them. Okay, the exam may ask you to prove them. Okay, the exam may ask you to prove them. All right, the exam may ask you to prove them. So now, for example, but you will see this in other videos. Okay, so for example, let's say now let's try examples. We'll try a few examples. Okay, so e.g. 1, given cos x minus y equals cos x cos y plus sin x sin y, derive a formula for cos x plus y. You see this? So they may ask you something like this. Now in our solution, so solution for this, we will say, okay, we have cos x plus y. Right, we have cos x plus y. We can imagine it as cos x minus y, isn't it? Now you can see cos minus is what we have. So we can then say, okay, we have cos x, cos, it's no longer y but minus y. All right, then plus sine x, and then sine minus y. Now, negative angle of a cosine is always positive. So this becomes cos x cos y. Negative angle of sine is negative. Then this becomes negative sine x sine y. You have proved, or you have derived this formula, right? You have derived this formula. Happy? Perfect. Now moving on. Let's see now. Let's try another example. Okay, let's try another example. So another example that we're going to try will be, let's say now we will say, let's see, we have, let me see, we are on, okay. So now example, I'm going to say 2. So in fact, it should be 3, but let's say 2. So we say if cos alpha equals P, write the following in terms of P. Write the following expression. Yeah, write the following in terms of P. In terms of P. What is that? Cos alpha over 2 minus 45 degrees multiplied by sine alpha over 2 minus 45 degrees all over 2. Then we say, oh, I see this is a compound angle formula. So we say cos alpha over 2 cos 45 degrees. Because it's a minus, it must be a plus. We did prove it earlier. Now we then have sine alpha over 2 sine 45 degrees. Okay, put them in a bracket. Then we have sine alpha over 2, because it's sine, it'll be cos, sine cos. Cos 45 degrees, it's sine, so it's minus minus. Then cos alpha over 2 multiplied by sine 45 degrees. Oops. Multiplied by sine 45 degrees. Let me just do this. I don't know where I'm going. I'm not staying on the line. I really don't know why I'm not staying on the line. Minus cos. Minus cos. So the, multiplied by sine 45 degrees. All these over 2. All right. Proceeding. Here, sine cos 45 is root 2 over 2. So we have root 2 over 2 multiplied by cos alpha over 2 plus, once again, sine 45 is root 2 over 2 multiplied by sine alpha over 2. Then this bracket multiplied by cos 45 once again is root 2 over 2 sine alpha over sine alpha over 2 minus sine 45 is root 2 over 2 multiplied by cos alpha over 2. All right, multiplied by cos alpha over 2 close all over 2. Common factor. Let's see. Okay, no, sorry. FOIL method, not common factor. FOIL method, but yeah, common factor would have worked as well. FOIL method. Let's see. FOIL method would be root 2 times root 2 is 2. 2 times 2 is 4. So 2 over 4. I'm seeing 2 over 4. Let me do it like this. 2 over 4 sine 2 sine square rather. Alpha over 2 minus 2 over 4 cos square alpha over 2 all over 2. Remember, here you do the FOIL method. It'll give you this answer. With what I'm seeing here, I'm seeing a difference of 2 squares. All right, I'm seeing a difference of 2 squares, but I see a common factor of, I have a negative cos square. Let me take out negative 2 over 4 as a common factor. Okay, then what am I left with? Cos square alpha over 2 minus sine square alpha over 2. This you have seen before. It looks like double angle, isn't it? It looks like double angle of cosine. Negative 2 over 4 divided by 2 is negative quarter. And this guy here, let me just talk about him. If A equals alpha over 2. What is 2a? 2a will be 2 times alpha over 2, meaning 2a equals alpha. So our double angle here is cos alpha. Now the question said, if cos alpha equals p, write the following in terms of p. Now we have cos alpha. Our answer will therefore be negative 1 over 4 times p. We are done. Okay, we are done. Happy? Perfect. Now we can go to, let's see how much space we have in this. Okay, now we're going to item 6. Item 6. Now moving on, we go into the sine rule, cosine rule, and area rule. Okay, and the area rule, applying them in triangle A, B, C. Okay, so let's begin with the sine rule. So for the sine rule, we have, it is in this way: sine angle A over side A equals sine angle B over side B equals sine angle C over side C. Now, what you need now is this. You then need, by the way, you can also swap them around and say A over sine angle B equals A over sine angle A. Let me just write them down. A over sine angle A equals B over sine angle B equals C over sine angle C. Okay, so when do we use sine rule? When do we use it? I want you to be careful. When given a side and its opposite angle and given another side or angle, but missing opposite. If given a side, you're missing opposite angle. If given angle, you're missing opposite side. So the order here is intentional. Okay, let me highlight this. The order here is intentional. Okay, the order here is important. If you are given another side, you will miss the opposite angle of that side. If you are given another angle, you will miss the opposite side of that angle. Okay, thank you. Now let's go to cosine rule. Cosine rule. This one, a squared equals b squared plus c squared minus 2bc cos angle A. Right, cos angle A. Moving on. So as we move on, when do you use it? When do you use it? 1. When you have two sides and an included angle. Okay, when you have two sides and an included angle. So here you're going to calculate the side opposite the given angle. Two sides and an included angle. So with an included angle, what it means is that the the angle given there is not opposite any of the two sides. Okay. Secondly, you can use when given all sides. Then that's when you determine the angle. Okay. When given all sides. Okay. Sorry. When given all sides, this is when you use cosine rule. Now, let's go to area rule. Let's go to area rule. Area rule for triangle ABC. So, area of triangle ABC, we know area is half base times height. If you don't have the height, you can use this. Let's say BC sine angle A. You can also say AC sine angle B, or you can say AB sine angle C. This formula is given in your data sheet. So usage when given two sides and an included angle. Okay. When given two sides and an included angle. When given two sides and an included angle. Okay. When given two sides and an included angle. Let me squeeze it here. When given two sides and an included angle, this is when you can use the area rule. Now let's go to trig functions. We are almost there. 7th item, trig functions. We are not going to draw them, but I'm going to explain a few things. So you have, let me use f of x. F of x equals a sine open bracket bx plus p plus q, or f of x equals a cos open bracket bx plus p close plus q, and lastly f of x equals a tan open bracket bx plus p plus q. I'm going to start with this p. So this p represents horizontal translation or shift. Okay, represent horizontal translation, like was the case with all other functions. If p is positive, the function shifts to the left. If p is negative, your function shifts to the right. Okay, this goes for all of them. Let's talk about q. It represents vertical translation. Okay, so if q is positive, function goes up, shifts up. And then if q is negative, function shifts down. Okay. Sorry. Now, let's then look at this b. This b, it's a, it has stories, but interesting stories. The first part, it tells number of cycles in the domain. Because I used x here, I will say in the domain x is an element of, let me just say included, 0 degrees to 360 degrees, all also included. Okay, it tells number of complete cycles. Okay, Secondly, indicates the period, okay? Indicates the period. So that period could be 180 degrees over B. This is when you're looking at tangent. Or 360 degrees over B. When? This is when looking at sine and cosine graphs. Okay. For sine and cosine graph, this is your period. So here says you have a complete cycle after how many degrees? That's what it means, okay? You have a complete cycle after how many degrees? Okay. Then another thing that is hardly spoken is this. If no horizontal shift, okay? If no horizontal shift, it represents scaling factor. Okay, it represents scaling factor. So for tangent, it'll be 45 degrees over B. And then for sine and cosine, it'll be 90 degrees over B. This is for tangent. And this is for sine and cosine. Okay, this is for sine and cosine. Okay, this is B. So this scaling factor you will see in the last video, in the last item. What do we mean? We mean sometimes when you draw your graph, you want to know if you should vary it with 90s or 45s or 30s or whatever. Okay, but this B will help you to scale it, okay, horizontally. Okay, to scale it horizontally, to scale your horizontal axis. Now let's talk this A. This A represents amplitude. You see it more. You see it more with sine and cosine. You can't really see its influence on tan graph. Basically, tan graph doesn't have an amplitude. Okay, so with the cosine and sine, this A represents amplitude. Okay, it represents amplitude. The highest and lowest points of a graph as well could be derived from this. It can help you derive that, but there's more to it. Okay, so this is all we can say about trig functions. All right. Now the last part, general solutions. General solutions. General solutions, I want to explain an important aspect of it. They give, it's basically a pattern of roots, okay, of trig functions. So what do I mean by that? Of trig functions. So basically it tells you where you will get your roots. Now let's say, for example, now we're going to try, for example, e.g., let's say f of x equals sine 2x. From the lesson we just had now, we know that this, from the lesson we just had now, we know that this guy here, sorry, when we draw him, because it's sine 2x, when we draw him, we need to say 90 divided by 2, which is 45. So we must vary our axis with 45 degrees. All right? We must vary our horizontal axis with 90 degrees. Yeah. 270 degrees, 315 degrees, and then 360. Okay, maximum and minimum is 1 and minus 1. Okay, so because this is sine graph, it will be moving like this. We're gonna have our cycle will complete at 180, the first one. Now we go and look for the other one. Nice, eh? Etc. So what is this? You can see now that our period will be 360 divided by B. And here is it. It says we complete the first cycle at 180 degrees. Let's confirm what we just said. This is what we said previously. You see this period? 360 degrees divided by 2 is 180. Indeed, it was 180. You see, plotting this with 45s somehow assists us to get a proper graph. All right? Now, what if then we say, now, what if now if f of x equals 0, 5, what are the roots? All right, what are the roots? So now let's take this guy here and say, let's say this is 0, 5. Eh? Right? Do you see this? So let's say this is 0, 5. But we want to know, or we do not know what these values are. But what I can tell you is this: sine 2x equals 0, 5. 0, 5 is half. I know that sine inverse of 0, 5 will be 13. But hold on, we don't have sine x, we have sine 2x. So 13 divided by, hear me out, 13 divided by 30 divided by 30 divided by 2 will be 15. So I suspect here it'll be 15. Okay, I suspect here it'll be 15 degrees. And I'm seeing that we get our period was 180. So we'll get another point that is in phase with it after 180 degrees. So meaning add 180 to this, you will get 180 plus 15, it'll be 195. Right? So this is me. I'm solving for x. Now, I recall when I did general solutions, not general, reduction formula. I remember that sine is positive in the first and the second quadrant. Remember, in the first quadrant, all ratios are positive. Now, hold on. How about I say, second quadrant, I have sine, rather 2x equals 30 degrees. But hold on. Now, for the second quadrant, I can say 180 minus 30, which is 150. But that will be 2x equals 150. Then I say, no. Let me, because it's 2x, not x, 150 divided by 2 will be 75 degrees. But this point occurs after 180 degrees. So another point that is in phase with it is this one here, which will be 275 plus 180 will be 225. No, 255 will be 255. You see, this is what you are getting without using general solutions. Now let's use general solutions, because some of you were wondering, what just happened? Now let me just show you now. The reason you are doing general solutions is this now. I said general patterns are a pattern of roots of your trig functions. It'll tell us of in phase point. Now let's see. We said f of x equals 0, 5. This is our solution. Okay? So what is f of x? It was sine 2x. So we're saying sine 2x equals 0, 5. Right? Okay, cool. Now we need a reference angle, which will be sine inverse of 0, 5. Agree with me that this is 30 degrees. When you press your calculator, it'll give you 30 degrees. All right. Now we ask, where is sine positive? Sine is positive in the first and third quadrant. Sorry, in the first and second quadrants. Right? In the first and second quadrants. Now for the first quadrant, we will say, oh, our angle here is 2x. So let's say first quadrant, 2x equals, we take the reference angle as is, we don't manipulate it. So equals 30 degrees plus 360 degrees k, where k is an element of an integer. Right? We are not looking for 2x, but rather for x. So x equals 30 divided by 2 is 15. 360 degrees k divided by 2 is 180 degrees k. So this is sort of a general term for the first quadrant. Now let's go to the second quadrant. For the second quadrant, we have, once again, 2x equals, second quadrant, we work with 180 degrees minus. So here, it'll be 180 degrees minus the reference angle, which was 30 degrees, plus 360 degrees k, where k is an element of an integer. Moving on, 2x equals 180 minus 30 will be 150 degrees, plus 360 degrees k. Now, we are not looking for 2x, but rather for x. Therefore, x equals 150 divided by 2 is 75 degrees. 360 degrees k divided by 2 is 180 degrees k. So I can tell you now, if k was 0, we would have these points. We would have these points here. Let me say 15. You agree with me? You would have 15. So with general patterns, now let's see. We will then say, okay, to get the next point, because this is our general term. Remember, it looks like a linear pattern. So to get the next term, we add 180 to 15, which will be 195. Then you add 180 to 195. What do you get? 375 degrees. All right. Okay. What if then I want to get a term before 50 degrees? That term, I will have to subtract 180 from 15. All right. So I will say simply 15 minus 180, which gives me negative 165. Now, let's come to this one here. I can take the 75 degrees. And if I want to get the next one, I will say 75 plus 180, which gives you 255 degrees. Right? Which gives you 255 degrees. If I add another point, I add another 180, it'll be 435 degrees. Now, if I want a point that is before 175, but in phase with it, I mean, a point that is before 75, that is in phase with it, I will say, no, 75 minus 180, which gives me negative 105, I think, negative 105. But now, I want to go to the diagram. Let me go to the graph that I drew. So you see here, I had stopped at 360. So I want to say, if f of x equals to x, let me add this and say x is an element of included 0 degrees to 360 degrees included as well. So what do? We're like, oh, So this information does not require me to have negative angles. It only requires me to have angles that are between 0 degrees and 360 degrees. So I then see, oh no, I will have to eliminate those that are outside my domain. For example, this is outside my domain. This is outside my domain. Outside my domain, outside my domain. Therefore, if they were to ask me what are the values of x, I will say x is equal to 15 degrees, x is equal to 75 degrees, 195 degrees, and 255 degrees. So I got these values earlier. Did you guys remember? Now, when they say what is the general solutions or determine the general solutions, I leave it here. When they say general solutions, I leave it here. Okay? Here, that's general solutions. But if you want to find particular points, you then do what I did here. Okay? You do what I did here. Eliminate those that are not within the domain. Okay? And this is how you do it, guys. If you can master this, you have all your 50 marks of trigonometry. So with that being said, it's a wrap, guys. See you next time. Bye-bye.